Hi, in this video we're going to cover what it means when a limit exists or does not exist. This video is going to emphasize graphically whether a limit exists or does not exist. So how do we tell if a limit exists? Well, let's look at example number 1. So here we have a function, and what it appears to be is it seems to be going like that, and this one seems to be going like that, and there appears to be a solid line or a solid dot in there and an open dot right here. So does this function exist? Does a limit exist? Well, the definition of whether a limit exists means that the limit has to be equal to the left-hand limit and the right-hand limit. What does that mean? Mathematically, this must be the case. So, limit as x approaches, let's call it a, positive, and limit as x approaches a, negative. Now a is just some arbitrary value that the limit may converge to, or may approach. Sorry, not converge, but approach. So as long as these two values are equal, the limit simply exists. If they are not equal, the limit simply does not exist. It's that simple. So generally speaking, as x approaches a. Now, if both of these approach the same value, then we can say in general the limit exists as it approaches that particular value. So graphically, how does this all work out? This positive a is not necessarily like a positive a, it means x approaching a from the right-hand side of the function. And this one is the value that it approaches coming from the left of the function. So I'll use, I'm going to use my fingers to explain this part for you guys. So let's look at this guy over here. Notice that the function we're coming, so in this case we're coming from the right, and let's say this value right here is a. And let's call this guy 3 and this guy is 6. So let's get right into this. So if I come in from the right, we see that it seems like the limit will approach 6 as it approaches a. Now if I come from the left, the limit appears to approach 3 as I approach a. So from the right hand side I get 6, and from the left hand side I get 3. So what does that mean? Well, it means that the limit as x approaches a, in this particular case, the function, the limit itself does not exist. So graphically, we say that does not exist. So the limit does not exist. Now let's look at this graph over here. So in this case, if I'm approaching, so again, let's call this value a. As I approach a from the left-hand side, it seems that this function is going to shoot up to infinity. That's right, viewers. It's going to go all the way up to infinity. What about if I'm approaching from the right-hand side? The limit shoots down as it approaches a. So it goes to where? Negative infinity. So positive infinity from the left-hand side and negative infinity from the right-hand side. So what does that tell you about whether this limit exists or does not exist? You guessed it. The limit does not exist. Why? Simply because the right-hand limit and the left-hand limit do not converge at the same y value. That's it. Now let's look at this function over here. So let's say the value of a is going to be, in this case, right there. So as I approach this function, as I approach a from the right hand side, it seems like I approach, let's say this term, let's call that term, let's say that's 3. So it seems like it approaches 3 from the right hand side. What about from the left hand side? So I'm going to go like this, like that, like that, like that. Oh, okay. So yeah, it looks like it approaches the same value. So what does that mean if the left hand side and the right hand side approach the same y value? We say then that the limit exists. And what is the limit if it exists? You know, you'll get that question a lot in the textbooks and stuff. They're going to say, so if it does exist, what is the value? So in this case, you'll say the value is 3, right? Because that's the value at which the limit approaches a, it becomes 3. So lastly, let's look at this graph over here. So as I approach, so again, this value over here is a, and let's call that 3. So as I approach a from the right hand side, it appears that I get 3, and as I approach a from the left hand side, again, it appears I get 3. So what does that tell you about this function? It tells us that the function exists, regardless of whether we have a hole. We call that a node. Regardless of whether there's a node, so I'm going to write that down, so node. Regardless of whether there's a node, as long as it approaches that same value from the right hand side and left hand side, then the limit simply exists. And what is the limit? Well, 3. That's the value at which the limit as it approaches a, it will go to. So hopefully this notation will help you guys, and I hope that the graphs will makes more sense to you guys, and kind of get a better conceptual understanding of what a limit actually is graphically. I want to end this one with one last graph, which I feel like it might help you guys. So let's get rid of all this. Okay. So the graph that I want to present you guys is this. So the question is, does the limit of that function exist? Now let's do the same trick that we do. In order to find whether a limit exists at that particular value a, we simply go from the right hand side and approach a. Boom, it shoots all the way up. These dashed lines, by the way, are asymptotes. Asymptotes are a region of like nothing exists in that entire region. So let's go from the left hand side. Boom, again, infinity. So notice that these are both shooting up to the same infinity value. What does that mean? It means that the function simply exists. And where does, not the function, I'm sorry, the limit exists. And where does the limit approach as it approaches a? Infinity. So we say that the function, the limit as it approaches a, approaches infinity from the right hand side and the left hand side, and as long as the right hand side equals the left hand side, the limit exists at that particular value. So the answer for this question would be infinity. Simple as that. So this is kind of like a graphical introduction to kind of get you guys, used to the whole idea of the limit graphically. So yeah, I hope this video was really helpful, and I'll see you in the next video. Thank you guys for watching. Alright, take care. Bye bye.